Hello friends and welcome to YouTube channel Freedom Tech. And in this session what we are going to learn? In this session we are going to configure yolov8 object detection. Also we are going to create our own custom object detection model for yolov8 on latest Raspberry Pi OS bookworm 64-bit version. But before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much. And let's get started. So friends, today we are going to install yolov8. Also we are going to create our own custom model for yolov8 on latest Raspberry Pi OS bookworm 64-bit version. For that I have created a new repository. This is completely fresh installation of bookworm on Raspberry Pi 4. Simple. So as I mentioned, for today's session I have created a new repository. I will mention the link. You need to simply copy paste the link inside the browser, rpi bookworm yolov8. Then go to the code, click on download zip, and it will download our zip format repository. As you can see, we successfully download our repository. Now minimize the browser, go to the file manager and go to the downloads. This is what our repository in zip format. Right click, then click on extract here, and it will extract with our folder name. So rpi bookworm yolov8 -main. Just click on cut, go to the home and just paste here our repository. That's it, we have done. So now first we want to install a packages. So just open terminal, and as I mentioned, this is completely fresh installation of bookworm. So if I run here sudo pip3 install OpenCV-Python. This is what our first package for yolov8. Sudo space pip3 space install space OpenCV-Python. If I hit enter, then as you can see, you will face this kind of error. So for that, simply inside our repository I have created a simple text file, rpi bookworm.txt. So right click, open with the text editor, and then here we have our first command. As you can see, this one command, sudo rm. So just copy the command, copy it, open terminal, and then just paste that command inside our terminal and just hit enter. That's it. Now clear the screen and minimize the text editor, minimize file manager. Now if we run our pip3 command again, so of course for Ultralytics, for yolov8, first we need OpenCV. So sudo pip3 space install space OpenCV-Python, and if you hit enter, and then now as you can see, now it will install OpenCV on our Raspberry Pi bookworm operating system. So when you install completely fresh bookworm on Raspberry Pi 4, first you need to run this command. So just copy it and paste inside the terminal and just hit enter. That's it. Now we can simply install our packages with the help of pip3 on Raspberry Pi bookworm 64-bit version. So it will install our OpenCV-Python package. Meanwhile, I will pause the video. So friends, we successfully install OpenCV-Python. So for Ultralytics, we want to again open our text editor file, and here it is. As you can see, this is the second command. This is the second command for Ultralytics. For Ultralytics, we need a particular version of torch package, torch vision and torch audio. So I have mentioned the full command. You need to copy the second command, copy it and just paste inside the terminal, and then remove this for yolov8 because this is only text. So the command like this way, it will look like this way: sudo space pip3 space install space torch 2.0.1 version, then torch vision, then this is the version of torch vision and torch audio, and this is the version of torch audio. That's it. Then just hit enter. Now as you can see, it will install our all packages. So friends, we have completed our installation talk, talk vision and talk audio. Now we can simply install Ultralytics. So let's just clear the screen, and again we want to run the command sudo space pip3 space install space Ultralytics. This is what our command, sudo space pip3 space install space Ultralytics, and then just hit enter. So friends, as you can see, now it will install Ultralytics on our Raspberry Pi bookworm 64-bit version. So friends, as you can see, we successfully install Ultralytics package also on our Raspberry Pi bookworm. Sudo space pip3 install Ultralytics, then it will install Ultralytics. Done. Now let me again clear the screen and clear, and then one last package, which is sudo pip3 install cv zone, sudo space pip3 space install space cv zone, and it will install cv zone. So friends, as you can see, now it's installing cv zone. Done, successfully installed cv zone. Now we successfully install all our packages. Simply minimize the terminal, close the text editor and open our Thony Python IDE. So go to the menu, programming, Thony, then click on switch to regular mode, click on OK. Now close the Thony Python IDE, again go to the menu, programming, Thony Python IDE. That's it. So we successfully open our Thony Python IDE, and on latest Raspberry Pi bookworm we have Python 3.11.2. Simple. So I have already created a code for yolov8 basic object detection. So let's just open our code, and here I am going to use a Raspberry Pi 4 camera module. So if you don't know how to use or how to connect the camera module, Raspberry Pi camera module with Raspberry Pi 4, so I have already created the video. I will mention the link. You need to simply watch the video and then connect the camera module with Raspberry Pi 4. So I have already connect my camera module with Raspberry Pi 4. So simply open repository and cam.py. As you can see, right click, open with Thony, and it will open our code inside our Thony Python IDE. As you can see, import cv2, then pi camera 2, import pi camera. This is how we are going to call our Raspberry Pi 4 camera module, and yolov8 pre-trained object detection module, which we are going to use here, yolov8 n.pt, nano.pt, because we are right now working on our Raspberry Pi 4. So we are going to use yolov8 n.pt pre-trained model. Then coco.txt, inside our repository we have our coco.txt file. If I open with a text editor, so we have here our classes. Here it is. As you can see, we have here all the classes, person, toothbrush, that's it. So this is what our basic code. Then this is how we will get our coordinates for drawing the rectangle. So now let's just run our code. So let me close untitled, and if I start the code, it will first download our yolov8 n.pt, a pre-trained object detection model, and then it will start our object detection. So friends, as you can see, it's downloading yolov8 n.pt model. And then friends, as you can see, it's detected me as a person. Here it is. So we have successfully configured yolov8 on our Raspberry Pi 4, and it's detecting me as a person. It is completely live. We use our Raspberry Pi 4 camera module. It's little bit slow because on Raspberry Pi 4 right now I am recording also we are using yolov8n object detection. That's why it's really slow, but it's really work great with yolov8 n.pt model on Raspberry Pi 4. That's it. So we have successfully detecting our object with the help of yolov8 on our Raspberry Pi 4 using Raspberry Pi camera module. Done. So we have done with our basic object detection. Now we want to create our own custom model. So for that, simply first we need our data. So here we are going to detect Arduino Uno board and ESP32 board. This is what our custom object. So for that we need images. So images, we are going to use our live camera module and then we are going to capture images for our data. So for that, again open file manager, go to the RPi bookworm, and inside that I have create img.py code. So just open img.py with Tony Python IDE. Here it is. As you can see, we have opened our img.py with Tony Python IDE. So now it will capture 30 images with the help of our Pi camera. It will capture 30 images. Here you can simply increase the number of images as per your requirement. Suppose if you want to go with 1030 images, you need to simply mention 1030. So if you want to go with 5 images, simply mention 5. Then it will capture 5 images of object. So now we are going to capture Arduino Uno 30 images, also ESP32 board 30 images. So max frames 30. Then here c2.imwrite. Here we want to mention the folder where we want to save our images. So inside our repository we want to create a new folder. Let's just say images. Click on OK and then right click to the folder which we just create. Then click on copy as a path. Minimize the file manager and here from images let's just remove all these things and press Ctrl plus V. Ctrl plus V. V as a victory. Just press Ctrl plus V and it will paste our path of the folder where we want to save our images. So /home/pi, this is what our repository, and inside that we create our images folder. Simple. And then this img is basically name of our image. So here first we are going to capture our Arduino images. So Arduino Uno, and the extension of our image is basically .jpg. Now it will capture 30 images. Name of image is basically Arduino Uno with .jpg extension, and it will save all the images inside our images folder. Now what we want to simply move our Arduino Uno board in front of our Raspberry Pi 4 camera module in different angle. In different angle we want to move our Arduino Uno board, then it will capture each angle 30 images. Simple. So let's just save the code, and if I start the code, so we have done. So if you open the file manager, images folder, and inside that as you can see we have 30 images. If you go and if you open with image viewer, here it is. As you can see we have all 30 images. That's it. So for today's session I have only mentioned 30 images, but in real scenario you need more images. So we have done with Arduino board. Now here simply remove Arduino Uno and we want to mention here ESP32. Save it and run the code. So as you can see I have moved the ESP32 board in front of my camera module, the Raspberry Pi 4 camera module. Now if you open again the repository, this is what our repository inside images folder. So we have Arduino images, and then we have ESP32 board images. Here it is, as you can see, ESP32 board and then Arduino. So this is how we can simply capture our data using Raspberry Pi 4 camera module for custom object detection. So done, we have our data ready. Now we want our label IMG software on Raspberry Pi 4 bookworm. So for that, again open repository, and here I have mentioned label img.txt, simple text file. Right click, open with text editor, and this is what our package is. So just copy the first package, copy it, open the terminal, and just paste it here and just hit enter. It will install pyqt5-dev tools on our Raspberry Pi bookworm 64-bit version. So friends, as you can see, we have done now our label img package. So just copy it and just press paste, sudo pip3 install label img and just hit enter. Now it will install label img on our bookworm. So as you can see friends, we have done. Now let's just clear the screen, and there is error for label img on bookworm. Let me first show you the error, then we are going to solve our error for label img. So run the command like this way, label lab, just type the lab and press the tab button. It will auto complete our command, which is label img, then just hit enter. It will open our label img software. As you can see, it's open. Now here, as we always do, we want to select OpenDIR, then our repository, inside that we have images folder, and then inside that we have all our images. Then change save dir, again same repository, images folder, and click on choose. So we successfully select our dir folder and save dir. Now here we want to select YOLO, so just click on and just select the YOLO. Then click on create rectangle box, and if you move your cursor for drawing the rectangle, then software is closed. So how to solve this error? For that, simple, just close all these things and then open file manager and go to the file system root, and then go to the USR folder, then go to the local folder, then go to the lib folder, then Python 3.11, this is what our Python version, and these packages, and inside that we have lib folder. So here we want to search for lib folder. As you can see, libs, libs folder, just click on it, and here the canvas.py. So this is the default canvas.py, and inside our repository, if I open again new file manager, and this is what our repository, and inside that repository I have mentioned the new canvas.py. So we want to remove this default canvas.py, and we want to simply mention our new canvas.py inside our /usr/local lib Python 3.11 these packages and libs folder. So here we want to remove this one file, and simply we want to change with our new file which I have mentioned inside our repository, this one canvas.py. So simply open the terminal, and first what we are going to do, we want to simply copy this path. So just select and copy it, the path, just like this way, copy, open terminal, and then run the command like this way, sudo space rm space -rf. This is the command, sudo space rm space -rf, then again space, and then just paste our path. Let me check here. This one, this is what our path, we copy it, and if we open our terminal, right click, yes, now simply click on paste, and as you can see, we paste our path where we have our canvas.py. So this is what our folder path for libs, and inside that which file we want to delete. We want to delete our canvas.py. So just mention canvas, or you can simply, if I open libs folder again, and if you copy the path of our file which we want to remove, like this way, canvas.py, just right click, then click on copy as a path, again open terminal, and then just remove the path and just paste the path which we just copy, just paste it. Now here it is, as you can see, we have our file. So simply we can now hit enter. So just hit enter, and if you open libs, as you can see, now there is no canvas.py. Now we want to move our canvas.py from repository to our folder which is libs. So simply what we are going to do, we want to simply open a new tab and run the command cd space our repository. If you run here ls command first, cd, and our repository, this one, rpy. So cd space rpy, just press tab, it will auto complete our repository name, then just hit enter. If you run ls command, and the file which we want to move, the name of that file is canvas.py. So run the command like this way, sudo space mv means move command, sudo space mv space, mention the file name which we want to move, which is canvas, ca, just press tab button, because we have here cam.py, so let's just say can, then it will auto complete our file canvas.py. That's it. So sudo space mv command for moving our file. So which file we are going to move? We are going to move our canvas.py. So sudo space mv space canvas.py, and where we want to move? We want to move inside our libs folder. So again copy this path, just right click, copy it, open terminal, and just paste it over here, just paste it like this way. So the command is now like this way, sudo space mv space the file which we want to move, then again space, and where we want to move. We want to move inside /usr, local, lib, python 3.11, disk packages, and libs folder. Now just hit enter. Now if you open libs, as you can see, we successfully move our new canvas.py file inside libs folder. Done. Now just go back, and one more file which we want to change. So for that we want to go inside label img folder. Here it is, as you can see, this one, the label img. Just click on it, and here we have label img.py. So we want to move this file also with our file. So inside repository I have mentioned, here also as you can see I have mentioned the label img.py. So same way, just select the file, copy as a path, and open terminal, then here run the command, same way, sudo space rm space -rf, and the path which we copy it of our label img.py, just paste it, and then just hit enter. Now if you open label img, there is no label img.py because we remove it. Now the new tab here, so here we are now inside our repository. So same way, sudo space mv space, so name of our file which is label img.py, let me check, this one, label img.py, as you can see, this one. So sudo space mv space label I capital label img.py, this is what our file which we want to move, and again simply where we want to move inside our label img folder. So just copy the path, open terminal, and just paste it, and then just hit enter. That's it. Now if you open label.img, there is our label.img.py which we change. Done. Now close all these things, just close it, and this terminal we are going to minimize. Now we are ready. Let's just clear our screen. Now we want to run our label.img software. So label, LAB, press tab button, it will auto complete our command. If you hit enter, and that's it, we open our software. Now same way, open dir, go to the repository. Inside that we have images folder. Inside that images folder we have our all images. Choose, this is what our images with our object Arduino Uno board. Again we want to change the save dir, so go to the repository, same folder, images folder, click on choose. That's it. Now here we want to select our YOLO, so just click on YOLO, and now create rectangle box, and now as you can see the software is working. The software is not deleted, or not deleted, basically software is not shut down, it's still open. Now here simply mention our class name, Arduino -Uno, Arduino Uno, click on OK, save image. So if you go inside our repository, open the images, and as you can see this is what our first image and their text file. So if you open the text file with text editor, and this is what our rectangle coordinates for yolov8, means our label.img is now successfully working on latest Python 3.11 version on bookworm 64-bit version. That's it. Now simply we want to draw a rectangle box on each image. So we save our first image, go for next image, create rectangle box, draw a rectangle box, click on OK because the class is same. Again save, next image, create rectangle box, draw a rectangle box on Arduino Uno board, Arduino Uno, click on OK, click on save, next image. So this is how now I will draw a rectangle box on each Arduino image. Now meanwhile I will pause video. So friends, we have done with Arduino Uno. Now as you can see this is what our ESP32. So same way, create rectangle box, draw a rectangle box on ESP32 board, and now we want to create our new class which is ESP32. Click on OK, just save it, go for next image, create rectangle box, draw a rectangle box, click on OK, save it, go for next image, create rectangle box, draw a rectangle box on ESP32 board, click on OK, save it. Now this is how I will draw a rectangle box on each ESP32. Meanwhile I will pause the video. So friends, as you can see we have done with drawing rectangle on each image with the help of label.img. So we have done with this process. As you can see this is what our last image. So let's just close our label.img software. We have done. Now open the repository, and this is what our repository. Inside that images, here it is, as you can see the Arduino, their text file, and then we have ESP32, each ESP32 image their text file. Here it is, as you can see. So we have done with label.img. Now here we want to create again a new folder. So I am right now inside our repository. Here it is, as you can see this is what our repository. So inside that repository we are going to create a new folder and mention the folder name same as I am going to mention. So create the new folder Freedom Tech. So right click, new folder, Freedom Tech, because in Google Colab file, this file I have mentioned the Freedom Tech folder. So you want to create here new folder and mention the name Freedom Tech. So I have created the Freedom Tech folder. Let me show you like this way. As you can see, Freedom Tech. Open Freedom Tech, and again here we want to create a two new folders. So right click, new folder, images, and then again next folder is labels. So create a Freedom Tech folder, go inside the Freedom Tech folder and then again create a two new folder. The first one is images and another one is labels. Now again go inside images folder, and here also we want to create two new folder. We need to create a two folder. So first one is basically training, and the next one is basically validation. Simple. So training and validation. Go to back, and same way go to the labels. Here also we are going to create training and validation folder. So right click, training, validation. Simple. Click on OK. So let me show you again. Go to the repository. Here we create Freedom Tech folder. Inside that we create labels and images folder. So again go to the images folder. Here we create training folder, then validation folder. Go back, again go to the labels folder, same way training folder and validation folder. Go back and go the images folder where we have our all images. Here it is, as you can see, the images folder. Inside that we have all our data, the images with the text file. Just select all the images, Ctrl+A, right click, then copy it, copy all the data, just copy it, go back, go to the Freedom Tech, images, training, paste here all the data which we copied. That's it. Same way, validation, just paste it. That's it. Then go back, same way inside labels we have training and validation, just copy paste all the data, just paste inside training data, and go validation, just paste it all the data inside validation also. So we copy the data from our images folder and we paste inside Freedom Tech folder, images folder, training folder, then validation folder, then go back, labels folder, training folder, copy paste the data, and validation folder, copy paste the data. That's it, done. Now we want to create this Freedom Tech folder as a zip file. So for that, again open label.img.txt. Inside that I have mentioned the command. So label.img.txt, just right click, open with text editor, and this is the command, this one, sudo space zip. This will create a zip file. So just copy the command, open terminal. Let me show you like this way, full screen, clear the screen, and now again ls command. We want to go inside our repository because inside that repository we have our Freedom Tech folder. So run the command like this way, cd space rpy, just press tab button, hit enter, ls command. Here it is, as you can see we have Freedom Tech folder. So just paste the command which we copied from our text file. This is the command. So this command will basically create Freedom Tech folder as a zip file along with the data which we have inside our Freedom Tech, images, training, validation, Freedom Tech, labels, training, validation. So just hit enter. As you can see, it's creating zip files. Done. So if you open your repository, as you can see we have freedomtech.zip. Now we want to move this file on our Google Drive. So friends, as you can see I have opened my Google Drive. So here simply right click, go to the file upload and select the file which we want to move. So our repository inside home, rpy bookworm and freedomtech.zip. This is what our file, freedomtech.zip. Click on open. Now it will upload our freedomtech.zip on our Google Drive. So here it is, as you can see now it's uploading. Here it is uploading. So meanwhile simply we are going to open our Google Colab. So here it is, I have opened my Google Colab. Then we want to upload our Colab file. So click on upload, browse, then go to the repository. So home, this is what our repository and this is what our Colab file. Select it, select. Now it will upload our Colab file on Google Colab. So friends, we successfully upload our Colab file on Google Colab. So go to the runtime, change runtime type, then select Python 3, and then here we want to select T4 GPU. Click on save, then click on connect. Now it will connect our Colab file. So friends, as you can see, we successfully connect. Now we want to run our cell one by one. So first cell, just click on play button, then the next cell it will install Ultralytics. So click on play button, it will run our next cell. So friends, as you can see, we have done. So just scroll down, go for next cell. So here we are going to import our module. So just click on play button, done. Now we are going to cross check our yolov8. So here it is, the model which we are going to use, yolov8 n.pt. As I mentioned, because we are on Raspberry Pi 4, so we are going to use a nano module yolov8 n.pt. So just select it, and it will cross check our yolov8 is perfectly installed or not on Google Colab. Using the image, the doc.jpeg, as you can see, doc.jpeg image from RoboFlow, and the result is basically saved. It means we successfully installed Ultralytics. Then now we want to mount our Google Drive, because on Google Drive we have our freedomtech.zip file. So if you go inside the drive, so we have done one upload completed. So we have done with uploading process. So simply we can mount our Google Drive. So click on play button. So click on connect to Google Drive. Then here we want to select the Gmail ID. Then just scroll down, click on allow, and now it's mounting our Google Drive. So friends, as you can see, we successfully mount our Google Drive, and here it is what our freedomtech.zip. Now simply we want to unzip our freedomtech.zip. So next command, click on next cell, and it will unzip our images. As you can see, Arduino Uno.jpg, the text file ESP32, that's it. So now we have done. Now what we want to create a data.yaml file. So just select the folder, this one, select it. Then go to the datasets. Here it is, as you can see, datasets. So just click on datasets and go to the Freedom Tech here, and these three dots, as you can see, these three dots, just select it and click on new file, and we want to create, as I mentioned, we want to create here a data.yaml. So data.yaml, just hit enter, and it will create data.yaml file. So now just click on that data.yaml and it will open our file. So right now there is nothing because the file is empty. So we want to copy paste the code from our repository. So again open our repository, and inside that I have mentioned data.txt text file. So open with text editor, right click, open with text editor, and this is the code. So just copy it as it is, just copy it. Open our data.yml, as you can see we open already, and just paste it here, the code, allow, that's it. We paste our code from our data.txt to our data.yml, and here we want to select our class names. So our first class is basically Arduino Uno, so mention here Arduino-Uno, and our next class is basically ESP32 board, ESP32 and Arduino Uno, and then class number of classes is basically now 2. So this is how you need to mention the classes name and the number class inside the data.yml. So right now we have only 2 classes, so I have mentioned the 2 class names, and the number of classes is basically 2. Simple. Then now press Ctrl plus S like this way, Ctrl plus S, it will save our file, then close it. Done. Now scroll down, and here this is what our training command. So here as you can see, model is basically yolov8s.pt, but as I mentioned, we are going to use a nano model, so we want to simply mention here yolov8 n.pt, and then now we are ready. We want to simply run our cell, and it will start 100 epochs. As you can see, it will start 100 epochs, and it will create our own custom model. With the help of this model, we can detect our Arduino Uno board, also the ESP32 board, with the help of our Raspberry Pi 4 camera module. So the process is started, and as you can see, the process is started 1 out of 100. So it will take some time. Meanwhile, I will pause the video. So friends, as you can see, we have successfully completed our process, and our model is basically saved inside runs detect train. So here it is, what our runs detect, then train folder, then we have weights folder, and inside that weights we have base.pt. So this is what our model. So just click here and download. Now it will download our base.pt model. So friends, as you can see, we download our model. So we want to move our model inside our repository. So click here, show in folder, and then this is what our base.pt. Right click, cut, then go to the repository, and the freedom tech folder, no, not freedom tech folder, here we want to mention, because this is what our repository, not freedom tech. So here we want to simply paste our model name. Click on paste, and then we have our base.pt. Done. Now simply close all these things, close the browser also, close this one, text file also. Now here minimize all these things, close terminal, open Thony Python IDE, and close img.py, and this is what our main code, cam.py. So here of course now we want to mention our own custom model. So instead of yolov8n.pt, we are going to mention base.pt. Now we want to create our own coco.txt file. Simple. So open repository, right click, new file, coco1.txt, and inside that just open with a text editor, and here we want to mention our class name. So Arduino, just a minute, Arduino Uno, and ESP32. That's it, Arduino Uno and ESP32. This is what our class name, and we want to I just create a new coco1.txt file for our own custom base.pt model. So we have done here. Now my file coco1.txt. That's it. Now all is good. Now if we save the code, if you run the code, so friends, as you can see, it started our Raspberry Pi 4 camera module, and as I mentioned, I am same time recording, so that's why it's slow. Now if I show Arduino Uno board in front of our Raspberry Pi 4 camera module, and as you can see, it's detecting Arduino Uno board. There is a rectangle box, and the class name is Arduino Uno. Then we have ESP32 board, and as you can see, now it's detecting ESP32 board. So friends, it means we successfully create our own custom model, and we detect our own customs object with the help of yolov8 using Raspberry Pi 4 camera module on latest Raspberry Pi OS bookworm 64-bit version. Remember one thing, we use here yolov8 n.pt model, so it's really work good, it's really work fast on Raspberry Pi 4. Because right now I am recording, that's why it's little bit slow. I hope you learned something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.